Assalamu alaikum class. In today's lecture, you will learn about the experiment for the discovery of neutron. You will also learn about the properties of neutrons and Rutherford's experiment and its conclusions. Now, as you know that electron and protons were discovered by J.J. Thomson and Goldstein, right? Then nothing extra was known up to 1932. Before this, the Rutherford was the scientist who discovered that the atomic mass is lying in the center of the atom, right, which is termed as nucleus. Now he also noticed that the atomic mass of atoms that could not be explained only on the basis of the electrons and protons, as the sum of the mass is left behind, which is not satisfied by the mass of the protons and electrons, right? For example, we say aluminium is having the atomic mass 27, but its atomic number is 13. So where the remaining mass of the element is, right? Now this confusion was solved by James Chadwick in 1932, who performed an experiment by using a radioactive element, that is polonium, right? This polonium metal, it produces alpha particles which hit the beryllium metal. The particle was ejected from these beryllium foil atoms, and then they were passed through a paraffin sheet. By reacting with this paraffin sheet, they produce protons, and these protons were then detected in the detector, right? So James Chadwick was awarded the Nobel Prize for this discovery, and the particle was named as neutron, right? He was the first one who found or proved that the neutral particles are also exist in the nucleus. Now here a complete experimentation is mentioned on this slide. You can see here this is a source of the radioactive substance, that is polonium metal, is placed within a lead block. This lead block, it blocks the radiation to come out from this source, as the radioactive substance is this polonium. So these radiations are lethal for the common person. So only a hole is present in it, which will allow the pass out of the alpha particles from this polonium metal, right? Alpha particles are actually the helium particles, this one with the +2 charge upon them, right? They are positively charged particles. In front of them there is placed a beryllium foil. This beryllium foil consisting of atoms of beryllium in it, and then further there is placed a paraffin sheet, and then there is present a detector which will detect the activity done, right? Now here we have alpha particles from this source. When they are bombarded on this beryllium foil, they eject neutron from it in the form of radiations which are unknown radiations. Later they were found these are the electromagnetic radiations having no charge upon them, right? So these radiations, when they further passed through the paraffin sheet, they are responsible for the ejection of proton through it, as the neutron was found to have no charge on it, so detector cannot detect it. So indirectly it is being done that a paraffin sheet is placed in their path. This paraffin sheet is containing a number of protons in it. So when these neutrons they hit these paraffin molecules, paraffins are actually the alkanes or the hydrocarbon sheet, right? Ji? When they are placed in their path, so what happens? They eject protons from them, which can easily be detected by means of a detector. So this is how the phenomena is done, that is the discovery of a neutral particle took place by means of this experiment, right? Now the reaction which occurred during this procedure was that beryllium Be, which is having the atomic mass 9, and atomic number 4. It reacts with these alpha particles, right? That is having helium particles which have mass of 4 at atomic number 2. When they hit beryllium foil, they convert this beryllium foil into another particle which is carbon 6 with the atomic mass 12, and one of the neutron is ejected here, right, which further pass through that of the paraffin and produces protons, right G? Now this is what we say the experimentation done by James Chadwick in the form of discovery of neutron. Now a video is uploaded along with this lecture, so take a look of that so you will easily understand the result of this experiment, right? Now here, before we go to the properties of neutron, the equation for the James Chadwick experiment is mentioned here. Beryllium with 9 and 4 atomic number, when it reacts with that of alpha particles, that is 4 and 2, the mass is added, atomic number is also added. You can see here we get carbon 12 with 6, that 4 plus 2 6, and 9 plus 4 12, but here 12 is given where the 13th part of the mass is there. So here it is, a neutron is produced with atomic mass 1 and no charge on it, right G? So this is the equation that shows you the experiment of the James Chadwick. Now here the properties of neutrons are mentioned here. Now according to these properties, we say these particles, what you say, when they undergo decay, free neutron, when it undergoes decay, it produces 3 further particles, right? Which ones are they? Here it is given an equation. This equation is asked for the, what you say, what products are produced by the free decay of electron, free decay of neutron. It is asked in the exams, right? Now that's why it is important. N1 naught, when it undergoes decay, it produces a proton with a mass 1 and charge +1, an electron with no mass but having charge -1, and a very small mass carrying particle, negligible mass it carries, so it is given as N0 atomic mass, 0 mass and 0 charge on it. It is called neutrino. So we say 3 substances are generated or 3 particles are produced, that is proton, electron and a neutrino. Now these particles, as they are heavy particles, they cannot ionize gases, right? And these are highly penetrating particles. They pass through the substance, right? Now there are 2 types of the neutrons, one which are called fast neutrons and the other one which are called slow neutrons. When the neutrons, they travel with the energy of 1.2 mega electron volts, they are termed as fast electrons. And when they have energy below 1 electron volt, it is the unit of energy, right? Electron volts. They are termed as slow neutrons. They are not deflected in electrical magnetic field. Why? As they are neutral. They don't carry any charge. So there will be no effect of electrical and magnetic. These are the remaining properties of neutrons. They can knock out the high speed protons from paraffins, water, paper and cellulose. जैसे पीछे आपने experiment में देखा, paraffin sheet when was placed in front of the beryllium, जो foil है उसके पीछे रखे गया था. So when neutrons, they are produced from beryllium, they hit this paraffin sheet, they are responsible for the production of protons from them, which are further detected, right? Now here the 2 type of the neutrons, जैसे अभी आपने पीछे पढ़ा, slow और fast, 2 type के होते हैं. तो slow one are considered more effective than that of the फास्ट मूविंग इन द फिशन रिएक्शंस। फिशन रिएक्शंस क्या होते हैं, जहाँ पे एक मॉलिक्यूल्स, एक रेडियो एक्टिव एटम जो है वो फर्दर ब्रेक होता है इनटू टू, और फर्दर ये रिएक्शन चलता चला जाता है आपके पास में। इसमें नए न्यू प्रोटॉन्स, न्यू न्यूट्रॉन जनरेट होते चले जाते हैं। तो अगर तो ये रिएक्शन कंट्रोलेबल है, फिर तो आप इससे जो है बहुत सारे प्रोडक्टिव काम ले सकते हैं। लेकिन अगर ये आपके पास में अनकंट्रोलेबल है, तो फिर ये एक्सप्लोजन कॉज कर सकता है, जस्ट लाइक दैट ऑफ एन एटॉमिक बॉम्ब, राइट जी। देन फर्दर आपके पास में न्यूट्रॉन्स, दे आर यूज्ड एज प्रोजेक्टाइल्स के तौर पर यूज होते हैं इन द न्यूक्लियर रिएक्शंस में। हाउ, देयर इट इज गिवन, न्यूट्रॉन जब आपके पास में अटैक करता है अपॉन या हिट करता है टू नाइट्रोजन को, तो कन्वर्ट कर देता है, इसको ट्रांसफॉर्म कर देता है इनटू बोरॉन अलॉन्ग विद द फॉर्मेशन ऑफ द रेडिएशंस अब यहाँ पे जनरेट हो रही हैं साथ में, दैट इज अल्फा पार्टिकल्स, दे आर जनरेटेड और अल्फा रेडिएशंस आर प्रोड्यूस्ड, राइट। नाउ जरा चेक करें इसका मैस, 14 + 1 मिला के बनता है 15, जिसमें से 11 इज फॉर बोरॉन और बाकी बचा 4, दैट इज फॉर हीलियम। सिमिलरली जरा इनके एटॉमिक नंबर्स को भी चेक कीजिए, 7 के बाद कन्वर्ट हुआ इनटू 5, 7 - 5 दैट कम्स आउट 2, जो कि हीलियम के लिए, राइट जी। देन व्हेन स्लो मूविंग इलेक्ट्रॉन न्यूट्रॉन जो है वो हिट करता है कॉपर मेटल को, तो प्रोड्यूस करता है पहले गामा रेडिएशंस और उसके बाद बीटा रेडिएशंस। इसके लिए आपको याद रखना है फ्री डिके ऑफ द न्यूट्रॉन, जिसमें एक प्रोटॉन जनरेट हो रहा था, एक इलेक्ट्रॉन जनरेट हो रहा था और एक अदर न्यूट्रिनो जनरेट हो रहा था, राइट। तो ये फर्स्ट रिएक्शन जब न्यूट्रॉन जो है वो बम्बार्ड करता है ऑन दैट ऑफ द कॉपर मेटल, तो कन्वर्ट करता है इसको इसके आइसोटॉप में। यू कैन सी हियर इट्स मास हैज बीन इंक्रीज, दैट 65 से ये 66 हो गया बाय एडिंग द मास ऑफ न्यूट्रॉन प्लस इलेक्ट्रोमैग्नेटिक रेडिएशन जनरेट हुई जो कि गामा रेज हैं विदाउट एनी चार्ज ऑन देम, राइट। देन नेक्स्ट वन आपके पास में ये जो कॉपर आपके पास में आइसोटॉप जनरेट हुआ, इट इज अनस्टेबल, ये फर्दर ट्रांसफॉर्म हो जाएगा इनटू जिंक में। तो यहाँ पे जिंक का मास 66 आ गया आपके पास में, और बता इसका एटॉमिक नंबर जो है वो चेंज हो जाता है, दैट इज 29 से 30 फॉर जिंक along with the formation of beta radiations, right? Now, the next topic is the Rutherford's experiment. Rutherford performed an experiment after the discovery of protons and electrons. How these particles they are assembled within the atom. For this, he performed an experiment, a very famous experiment called the gold foil experiment in 1911, right, along with his co-workers. In this experiment, he discovered nucleus of an atom where the whole mass of the atom resides. Here how the discovery took place, that is done by means of an experiment. You can see here there is placed a block. This block is used as a lead block, which inside it contains the radioactive material that can be polonium metal or the radium metal, which is used for this purpose. Now in front of this there is placed a gold foil which having the thickness that is very low, 0.0004 centimeters. Very thin is the foil. This one, it is placed in the path of the alpha rays which are coming out of this slit present in this lead source or lead box, right. Around this foil there is placed a screen, this one screen, which is a photographic plate on which when the substance will hit, so it will produce fluorescence. वहाँ से जो जगह है वो शाइनी अपीयरेंस में आ जाएगी, जैसे फ्लैश पड़ता है इसका कैमरे का, तो वहाँ पे आपके पास में ब्राइटनेस आती है। सेम इज हियर, जहाँ पे जाके स्ट्राइक करेगा पार्टिकल वहाँ पे वो स्क्रीन ब्लैक से ब्राइट हो जाएगी, ठीक है जी। सो दिस इज द इंस्ट्रूमेंटेशन विच इज डन when alpha particles were bombarded upon that of the gold foil particles. तो इससे क्या आगे से क्या रिजल्ट आया, तो alpha particles they are going to pass through this gold foil. तो इसमें से जो conclusions लिए गए वो क्या थे, वो ये था कि ये जो अल्फा पार्टिकल्स हैं they were deflected by means of the different one angles, लेकिन mostly maximum of them they pass through without any change in their path, right, without any deflection, right? So, and there was a maximum deflection of up to 180 degrees, right G? But only one or two particles were having such deflection, the maximum deflection. Otherwise very small angles were there for the deflection, or mostly undeflected. So what the conclusions were made, that an atom consists of the small heavy positively charged portion, which is termed as the nucleus, right? Now this is the negatively charged portion which surround the nucleus containing electrons. Here I can show you the diagram like this. This is the atom. Here lies the center. The alpha particle when bombarded passing through this, यहाँ पे जाके स्ट्राइक करेगा तो वापस हो जाएगा, राइट? लेकिन अगर इसके एम्प्टी हिस्से से पास करेगा तो सीधा स्ट्रेट गुजर जाएगा, राइट? और अगर इसके बहुत क्लोज से पास करेगा तो देयर विल बी अ डिफ्लेक्शन, ठीक है? सो दिस इज हाउ द डिफ्लेक्शंस वर प्रोड्यूस्ड, राइट जी? तो जो आपके पास में द मॉडल था, इट वाज प्लेस लाइक दिस कि इट इज जस्ट लाइक अ प्लैनेटरी मॉडल, राइट? जिसमें सेंटर में आपके पास में जो है वो पार्टिकल वो है विच इज हैविंग द सेम चार्ज एज लाइक दैट ऑफ द हीलियम पार्टिकल, जिसकी वजह से वो डिफ्लेक्ट हुए, क्योंकि हीलियम पार्टिकल्स भी पॉजिटिव 2 चार्ज कैरी करते हैं, और सेंटर जो है प्रोटॉन्स आर देयर, दे विल आल्सो कैरी द पॉजिटिव चार्ज ऑन देम। तो यही हुआ कि न्यूट्रॉन जो न्यूक्लियस है दैट इज गोइंग टू कैरी प्रोटॉन इन इट, right? Then number of protons in the nucleus are equal to that of the number of electrons in this planetary motion, or what to say, the planet system which was concluded here. The electrons they revolve around the nucleus in the particular paths, and the two forces they are equal. That is, कौन सी forces act कर रही होती हैं एक सर्कल में घुमाने के लिए इलेक्ट्रॉन्स के ऊपर? एक सेंट्रीफ्यूगल फोर्स और एक सेंट्रीपिटल फोर्स, राइट? सो और इसका मोस्ट ऑफ द जो वॉल्यूम है न्यूक्लियस का और दैट ऑफ द एटम का जो है दैट इज एम्प्टी, द सेंटर इज ऑक्यूपाइड बाय दैट ऑफ द न्यूक्लियस, राइट जी? दिस वाज द एटॉमिक मॉडल प्रेजेंटेड बाय रदरफोर्ड। लेकिन इसमें कुछ डिफेक्ट्स थे। वो डिफेक्ट्स क्या थे? व्हाट वर दीज डिफेक्ट्स? आई होप यू पीपल आर फेमिलियर विद। एक तो ये कि अकॉर्डिंग टू द क्लासिकल इलेक्ट्रोमैग्नेटिक थ्योरी, when electrons are revolving around the nucleus continuously, so they must be losing some energy continuously. So gradually they will come closer, closer, closer to the nucleus, and then they will fall into the nucleus ultimately, right? So atomic system जो है वो तो collapse हो जाएगा, right? लेकिन ऐसा तो नहीं होता। Then दूसरा क्या था? That this model was based on the law of gravity पे। Law of motion can also be applied to the neutral particles पे किया जा सकता है, like that of planets, but not applicable on the charged particles like that of the electrons and protons पे। तो फिर इसको कैसे justify करेंगे? Then if electron emits energy, जब हम कह रहे हैं कि रिवॉल्व करता चला जा रहा है कंटिन्यूसली, इट इज रिवॉल्विंग अराउंड, तो इट इज एमिटिंग एनर्जी। वो एनर्जी जो है वो कहाँ जा रही है? अगर उस एनर्जी को हम पास करें थ्रू द प्रिज्म तो वी विल गेट a continuous spectrum, but actually we get a line spectrum. So that's why we say this gives the failure, or you say that these were the some defects in the Rutherford's atomic model. Right, Ji? Now this is what we say about that of the Rutherford's experiment. Along with this, I have placed a video for this experiment as well. I hope you will well understand it, right? Learn the both topics very carefully, right? And they are important topics, especially discovery of neutron, in which a number of short questions can be there, and the objectives can also be made from this topic, right Ji?